All right, so let's take problem number 7, right? So it's just converting a string representing a number to the actual numerical value, right? Typically, problems like this can be solved in one of two or three approaches, to be specific. The first approach is that you can solve this using ASCII, or to be specific, ASCII comparisons. That's annoying. Comparisons, right? And this is typically gonna have an O of n squared, because you're gonna have two loops in this kind of algorithm, right? And next you can use dictionary. Using dictionaries to store every string with its representative number, right? So the string is gonna be the key, and the number is gonna be the value, right? And this is typically is gonna be O of. It's gonna be a little bit better. This is gonna be O of n, right? And finally, using the built-in end function, right? And this is going to be regardless of how the end function is implemented, right? Whether it has a loop or not, I don't really care. But using this function, and regardless of how it's implemented, this is going to be of O of n. So this is going to be having only one loop. This is going to be having one loop that traverses n times. This is one loop that traverses n times. The ASCII is going to have the two loops that traverses n times. Right? It's typically the ASCII one is not going to be that O of n squared. Maybe it's going to be O of n to be specific, because the second loop goes from 0 to 9. Like it checks the numbers from 0 to 9. So it goes like 10 times every time. So we can consider this O of n, right? So all of them are O of n. Right? What I really prefer is the ASCII solution, but you didn't take the ASCII in the course, so I'm not gonna do this. And once we get to dictionaries, I'm gonna introduce this concept to you. But for the time being, let's stick with the end version. All right. So let's say that I have S here, which is 1, 2, 5, 3, 4. This is the number. All right, and we can do a for loop that using indexing, we are going to traverse through every element, and once we have 1, we're going to cast it into actually 1 and then multiply it by 10 to the power of in this case 4, right? It's 10,000 here, so it's 4 zeros, right? And you can tell that this 4 is going to be achieved from the length. You know, this is the length of 5 elements. If we say that the length minus 1, this is going to get you 4, right? And this is plus 2, which is 2,000. 2 multiplied by 10 to the power of 3. Notice that how the place is being decremented by a whole decimal place from 10,000 to 1,000. And next you're going to see that 5 is going to be multiplied by 10 to the power of 2, so from 1,000 to 100. So you can see that the place, decimal place is being, or the place, let's just call this part the place, decimal place, is going to be decremented or divided by 10 each time in each term. And this is going to be 3 multiplied by 10 to the power of 1. And finally, we have 4 multiplied by 10 to the power of 0, which is 1, right? So let's take that place. Let's say that the place is going to be 10 to the power of len, right? To the power of len that string minus 1, which in this case is going to get you 4. That's the greatest place, which is the place of the first element, index of 0, which is 1, which is 10,000, right? So what I want to do using the built-in end function is that, it's recording, right? Is that I can say that once I have that element, I can cast it into an integer and multiply it with the place. This is going to work just fine for the first one. So 1 is going to be casted into the number 1 and then multiplied by a place, which is 10 to the power of 4. Then this is going to get you 10,000, right? But what happens for the rest of the numbers? We want to make sure that when the index is at 1, so s of 1 is now 2, we have a place of 1000, which is 10 to the power of 3, not 4. So we want to make sure that this place is being minimized in every iteration, right? So let's say that we have a result that's going to be accumulating all the values like that, plus, and I think this does it. So let's just print this, and you're gonna have the same result, right? So let's see how can we do this iteratively, right? Now let me just open up the whiteboard for just a second. All right. Okay. So we know that this number is string, right? By the end of the let's take a recursive approach. Now I'm talking about the recursive approach, right? So I know by the end of the recursive calls, all of the recursive calls, I should have that number, that string that is representing a number, converted into the actual numerical value. So I should have the numerical value like this. So this is my end goal, or the end result, right? So if you look closely, you're going to see after casting every element into an integer, that, for example, after 1 being casted into an integer, you're going to have 1 multiplied by, let me just write it in plain mathematics, multiplied by 10 to the power of 4 plus 2 multiplied by 10 to the power of 3, just as we discussed earlier. And and we have here a 5 multiplied by 10 to the power of 2 plus 3 multiplied by 10 to the power of 1 plus 4 multiplied by 10 to the power of 0. Right? Notice how this, what we call as place, is being divided by 10 every time. Right? So it is dividing by 10 every time, right? Again. Right? So it's from 10,000 to 1,000 to 100 to 10 to 1. Okay? So it is really obvious that if I'm using recursion, that my base case, if I'm basing my base case on the place, I can say if place is equal to 1, then I can just return, return something that is not going to affect the addition. Notice that this is the main operation that is happening. So I can return something like 0, right? So if I return 0, nothing is going to be affected by just adding on a 0, right? Or someone would say I can base my actual base case or stopping condition when the index reaches something that is not inside the string, meaning that the index is out of range. So let's say that index here is going to be 0, 1, 2, 3, 4, and 5. No, there's something wrong here. 0, 1, 2, 3. I think I added an extra pointer here. So 0, 1, 2, 3, 4. We can say that when I actually becomes of the actual length of the string, then we can just return a 0. That's still not gonna affect the addition operation at all, right? So just by looking at the sub problems that we have actually tried to create out of our problem here, you can see that this is a sub problem and this is a sub problem. That's one, and that's one, and that's one, right? So you can tell that you have roughly a number of recursive calls that is going to be 4, right? Now, if we think about this for just a minute, let's see if we want to make a staircase like of the algorithm. How would it look like, right? And remember, I'm just taking this in a backwards fashion, right? Again, I mean that this is going to be my end result, right? Which is 10,000, or this is going to be my pre-end result, right? So this is my actual end result. So by the end of the algorithm, I should have a result of 1, 2, 5. Let me just put this here. 1, 2, 3, 5. That's the end result of that algorithm, right? But if you look closely, you're gonna see that this is consisted of what? This is consisted of this known part for you, which is in this case is gonna be 1 multiplied by 10 to the power of 4, which is 10,000, plus a value that is unknown for you. I know that you know that this is 2000 plus 500 plus 30 plus 4. I know that you can get that for the time being, but what I'm saying is that we want to dissect the problem into a known part and to an unknown part that is going to be dependent on the return value from our recursive calls, just as we did with the factorial and the sum evens and all of the previous algorithms, right? So there's some unknown here that I'm not really aware of. So this is my first recursive call, right? In my first recursive call, I don't want to say it's recursive call, it's just a function call. This is the first function call, but anyways, let's just say recursive call 1, right? So we're gonna have something, the known parts for me is basically, I know that I'm standing at index of 1, right? So I know the number, the index number, which is 0. Let me just put this as blocks right there. So I is 0, right? And I know that the place is going to be 10,000. And what else that I know? I know that the string is not going to be changed in this case. String is going to be like that, right? So in the next recursive call that the program is going to try to attempt to reach in order to figure out this unknown portion here, it's gonna look for the next step. In the next step, you know that you are going to stand on the next index, which is index of 1, right? Which is basically this part, right? So you know that you have 2000, or let me just say 2 multiplied by 10 to the power of 3, which is 2000. So you know that you have this part. This is the known part for you, right? Plus something that is going to be returned from an upcoming or an upper recursive call, right? So this is an unknown for you, right? So this is your recursive call 2, right? So you have I in this case standing at index of 1, right? And the place is typically 1000, and you have the string, which is basically the same thing, like that, right? Notice that we will have an optional parameters, as you can see here. This is really obvious, and this is the positional parameter. Okay, and there is actually a way, just the same technique that we use to reverse a string, there is a way to do it without an optional parameter, but I'm just going to stick with the optional one. Try to figure this on your own if you have time. All right, so in the next recursive call, we're going to target the 5, which is the index of 2 in this case. So we know that 500, or 5 to the power of multiplied by 10 to the power of 2 is 500, plus the unknown part that I'm not really aware of. Okay, so we're going to go to another recursive call where RC3, right? I think this is RC3. This is a mistake. This is RC3, where I is basically 2, and where place is basically 100, right? And the string is the same as before. Okay, and now let's go to another recursive call where we have 3 at index of this is index of 3, right? So now we have 3 multiplied by 10 to the power of 1, which is 30, plus some unknown that I'm going to figure out in the next recursive call. This recursive call is the 4th, and we have I of 3, and we have the place of 10, and the string is the same, right? And now we have the next one, which is basically the 4, right? This is the 4 multiplied by 10 to the power of 0, plus the unknown part that I'm not really sure what it is, right? And the place here in this recursive call of 5, the place, the I is typically 4, right? Index of 4, right? And the place is going to be something like 1. I'm sorry, the place here is going to be, yes, the place here is going to be 1. I think we did a mistake here. Yes, the place is going to be 1. Yes. I'm sorry. The place is going to be 1. All right, and the string is the same, right? And we can make another recursive call, and actually we can stop here. When the place is 1, then we can just return the same number. We can just return the value of I, integer of the string I. We can just say that if place became 1, right? So we can return the current string, right? But an integer version out of it, right? So we can just return that. So this is going to return only 4, which is going to be plugged in or returned to the upper, to the previous recursive call, which is 4 right there. So this is going to get you 34, right? And 34 is going to be returned here, and this is going to get you, when this returns, it's going to return as well 534. And when this returns, this is going to return 2534. And finally, when this returns, this is the actual function call, is going to return to the screen or to the user in a variable or something, that 2534. Okay, so we can stop at the base case where RC5 is my base case, or you can keep on going and check if the place is, or not place in this case. If you want to keep on going, you can check if the place, because you know place is being divided by 10. So once you have a place of 1, if you continued and divided that place, which is 1, by 10, then you're gonna have something like 0.1, right? 0.1, and the integer division is just going to leave the integer part. So if place was found to be 0, then I can just return 0. So I can return 0 here, and this is still going to give you 4, right? If the place was 0, right? Instead, I'm just going to, instead of doing that, if I have another recursive call, which is recursive call 6, place is going to be 0 in this case, right? So if place found to be 0, right? So I can just return the value of 0. Another way to look at it, if you went to recursive call 6, you can say that I as well is going to be 5. And so if I, just as we said there, right there, if I became equal to the length of 5, then we're just going to return 0. But the choice of stopping is really yours, and I really recommend that you do not go an extra couple of unnecessary steps. Like this is unnecessary step to go to recursive call 6. That's totally unnecessary. You can just stop at recursive call of 5, right? But anyways, let me just remove that part. All right, I think this is needed. Okay, so now let's do the stack diagram, right? So I know that I have how many recursive calls? Let's say 5 recursive calls, right? Like that. All right, and I know that this is the first function call. So if I have my driver code like this, and I am calling the actual function. Let's say that the function is defined somewhere here. All right, let me just make an extra space. Okay, so let's call it, let's say that I am calling the function that is called for number, and I'm passing the string, which is 1 2 5 3 4. Okay, so this should return to me the value of, notice that there are returning everywhere. So we are talking about not printing but returning a value. So this should return the string 2534. Right? So the function definition, let's start really simple. I'm not really sure what will be the function definition yet, but let's start really simple and say form number. And you can tell that there are optional parameters here, place and I, and S is the positional, the argument one, the one that is going to be always fixated, not going to be changed at all. And we are starting I from index of 0, right? And we are starting place as well, and this is the part that's going to be a little bit tricky to do, right? Let me just rewrite this because I need some space. Form number, so S I equals 0, and place equals len, right? So let's call this as len, right? So this is going to be place, which is going to be the same thing that we did inside the loop, which is 10 to the power of len, right, of S, which is the same parameter here. And this is typically is going to raise an error, but I'm going to discuss this once we get to the implementation part, when we try to implement this using Python. Right? So len S minus 1, which is going to be in the first recursive call, place is going to be with this fashion, with this number of elements, which is 5. So 5 minus 1, right? 10 to the power of 4. So this is going to give you 10,000, right? But this is going to give you an error. So let's just see what will happen, right? And we have the base case. We agreed on multiple things here. We can do the base case as we said in the recursive call 5. We can end it there. So if place, right? If place found to be equal 1, right? We can just say what? We can just say that return that kind of string as an integer, which in this case I'm talking about the 4. Return the 4 as it is, but as a number, because we're going to add to it, right? Okay, so this is my base case as we discussed, and let's say that I am going to, for every, let's look at this. Let's just write the base case here and go to the stack diagram on the right. So let's say that this is the first call. This is the first call, the first function call. It's not recursive, but I'm just going to say it RC for simplicity. So this is the first function call where we are calling form num and sending this ugly string. All right. So this is typically the top of the stack, right? We aren't really sure of what should we put in this area. So let's just figure this out together right now, right? So this is define form num, and we are sending that string. All right. Okay. And another thing to note is that we have the I defined as, let me just, we know that I is going to be starting at index of 0 and place is going to be initialized by 10,000, right? I don't have a place to write all of this, honestly, right? So I is 0 and place is 10,000 and S is like that, right? So we never hit the base case right now because the base case is really depending on the value. It really depends on the value of place. When we reach a place of 1, like this case, if we reach place of 1, this means that we have reached the 1's place. Then there is no need to divide the place any further. But if you looked at this pattern, the patterns that we have formulated here, like this pattern right there, right? And this pattern here, and this pattern right there, and this pattern right there, right? So you can tell that there is a known part for me, right? And there is an unknown part. The unknown part, as we always discussed, is being represented by the actual function call, the actual recursive function call. We really don't know what will this include, or would this include, or would this include, right? So this is typically a function call like this. I don't think I'll have a place to write all of this. So form, I'm just gonna write it if n form number, and you should know that this is abbreviation for the same function. This is not a different function at all. I just don't have a place to write everything, right? So we are calling the same function and passing the same string. Notice how the same string is existent in every recursive call, right? So we are passing the same string, right? And we are passing I that is going to be 1, then 2, then 5, then 3, then 4, then I is being incremented by 1, right? And the place is typically, as you see here, place once was 10,000, then it became 1,000, then it became 100. So place is being divided by 10. There's absolutely no place to write this. I don't know what should I do, to be honest. Let me just try to rewrite it again. Place divided by 10. Okay, and this is plus the known part for me. And the known part is typically what? The known part is typically, if I have the string, then I can say that I am taking string of I, which is s of I, right? So I have s of I, this is index of 0 for 1, right? And I can cast it into an integer, and then I can multiply it with, this is going to give you from string 1 or character 1 to 1, and I can multiply it with place, right? Again, let me just rewrite this. I can multiply it with place. So this is multiplied by 10,000 in this case. So this is going to get you the known part, which is basically 10,000. So this is the part that you are familiar with, and this is the unknown part, right? And hence we can say that this is the part that I was looking for. So this is basically the known part. This is going to be a return. Notice that there is a return statement that I forgot here, right? So return that known part for me, which is int of s of I, right? So if we started off with index of 0, so we have 1, so just cast it into an integer, multiplied by the place, which is 10,000, and boom, you have 10,000 right there. This is the known part, plus the function call, or recursive function call. I'm just going to write it downside here, for num, and that for num is going to take the same string in the next recursive call, right? And I plus 1, and place divided by a 10, minimized. Okay, we did this actually in the lab, but I wanted to write it one more time because I think some people didn't really get it, right? So there is a new function, or recursive function call, that's going to take place here, right? So now we are calling if n, and we are sending the same string, right? This is a string, by the way, right? And we are sending I, in this case, I equals to 1, right? And place is being divided by 10, so place from 10,000 is going to be 1,000, like that, right? So this is place. Okay, so place is now 1,000, and I is now 1. So we're looking for the index where I is 1, which is basically the element 2, right? So if I have the element 2 using the same exact part here, this part, right? So s of I when I is 1, right, is going to give you 2, right? When you cast this into an integer, it's just going to give you the number 2, right? Multiply this by the current place, which in this case it's 1000, so this is going to get you 2000, right? So this part is going to be the same as this, right? 2000, right? Plus the unknown part, which is calling the function, right, with the string, with I plus 1, the next index, with the place being divided by 10, like that, right? And there's a return. Okay, notice that I told you that this is not going to work, but I'm just going to solve it when we get to the implementation part. I just want you to get the idea, right? And now there is another function called, another recursive function called. So we are calling if n with string, with I that is incremented by 1, which is 2 in this case, with place that is equal to 100 in this case. So place, let me just write it with the same order. So S is going to be the same thing, right? And this is place, and this is I, which is 2, right? So now we have, I can't target the 5, but I'm looking for the 5. This is index of 2. So if we have index of 2, right? So now we have index of 2, right? So this is going to get you 5 multiplied by place, which is in this case, as you see here, 100. So this is going to get you 500. So this part, the known part, which is in this case A, is going to be 500. Oh, the glitch is happening again. 500 plus the glitch is really bad this time. I wouldn't be able to write it, I believe. Alright, you get the idea. You know that the recursive call is gonna happen here. Okay? And this is gonna be taking place in this part, where I is gonna be incremented by 1, right? So this is if n. This is getting so much bad. So S and I incremented by 1, so I is equal to 3, right? And place is going to be minimized by another 10 divided by 10, so this is going to be 10. So here place, let's write it with the same order if we can write in this portion of the screen. And place is going to be 10 and I is going to be 3, right? So now we are starting at index of 3, which is basically, that's a coincidence, that is 3, right? So S of 3, this is going to get you 3 multiplied by place, which is in this case 10. This is going to get you 30. So this is the known part here, like that, right? So this is 30 plus the recursive call that is going to open up a new stack frame. Okay, like that, where if n that's gonna have S and I incremented by 1, which is basically 4, and place equal to 1 in this case. So string is like that, and we have place, which is 1, and we have I, which is 4, right? So this is where the base case is gonna take place. So if place is 1, then we can just safely say, if place is 1, then we can just say return the current index, the current element, which is in this case 4, index of 4, right? Which is basically the same, this is the same value. So this is just a coincidence, right? So return that element, which is index of 4. So it is index of I, which is 4 in this case. That's going to return as well 4, but cast it into an integer, right? So now this return out there, right, is going to get you 4. So this is going to be returning 4, right? And once this is returned, this is going to pop from the stack, right? And this 4, this 4 is going to be taken and be placed instead of this unknown part, right? So this is going to be 4, right? Just like this part right there, right? Plus 30. So this is going to get you 34, which is here. So this is going to pop when this 34 is returned. And 34 is going to be, instead of that unknown part, which is in this case here. So this is, oh my goodness. This is 34, I swear, plus 500, so this is gonna get you 534, right? And this is gonna be popped once there's a return, and this is gonna be placed in place of that recursive function call, like that, here, plus 2000, so this is, right? And this is going to be popped from the stack and returned instead of the place that, or instead of the recursive function call that has triggered it, which is in this case here, right? So this is going to return, right? Which is going to be there, plus 10,000, right? So this is going to get you the same number, right? So this is going to get you the same exact number. Yes, this is going to be popped on the stack, right? So we're going to end up with that. All right. So let's try to run this and see the problem that I was mentioning to you about this part, this specific part. Okay, let's say that I will call this define Okay, I will call this define form number, and let's just call it what? Let's just call it fn form number, like that, right? And let's say that this takes a string, it takes an optional parameter, which is the first index, and takes another optional parameter, which is basically the place, which is 10 to the power of len of s minus 1, right? Now let's try to write the base case. So if place is found to be 1, then we can just return the last element being casted into an integer, return sfi after it's casted into an integer, right? And the main operation, or the core operation, is basically having what is ever being accumulated inside this part, right? Inside the recursive call part, the unknown part, right? So the unknown part is going to be here. So the unknown part is basically f of n being passed to it s and I plus 1, and then we have the place but being minimized by 10, like that, right? So anything that is being accumulated and returned from this recursive function call is going to be added on the known part that I'm familiar with, which is basically having the current element multiplied by the current place, right? So let me just put this inside brackets here, like that, right? And let me just return everything by the end of the function, right? So let's call function, and this is not going to work. Let's call this, and let's have the same s. Okay, like that. All right. So okay, so it shouldn't work. That's just a mistake. That's just a mistake, right? It's something related to Jupyter Notebook. What I'm opening here is the Jupyter Notebook, right? In Jupyter Notebook, there is a stupid thing that is happening because you know, this is right there. This is a global variable, and the function is thinking that this is that you're talking about is the same as that it is defined up there, right? So that is the problem, right? But typically what I'm referring to s here is a local variable inside the function. So if I just changed this into string, you're gonna see that the error is appearing here, and the error is actually in the header of the function. It is telling you that there's no problem with string here. The problem is in this part, because you are trying to initialize place via the variable that is called string, which is not still defined. Note something, these are optional or default parameters in Python, right? And default parameters or optional parameters are usually initialized before the positional ones, since positional ones are being taken manually from the user, but the default ones does not need to be manually taken from the user. It can be automatically, since it has a value, since it can be automatically initialized. So this is what's happening. String didn't have a value at the time being, and in the same time that string did not have a value in, place was trying to initialize itself using the value of string, which is non-existent at the moment. Right? So this is the problem here. It's telling you that I'm trying to initialize place, but typically I cannot find the value of a string variable. There's no string variable that is being defined. So this is my main problem. There is a small tweak to this program. All right, so before introducing the solution, I just want we to agree on some general rule, which is basically if you have an optional parameter in your function definition, and if it was a recursive or not, if you have an optional parameter that is dependent on another positional parameter, then this is a scream for an error, right? So just try to avoid that if this is something that you've noticed that you're doing in your code. So instead of having the place as an optional parameter, I'm just going to take it all away, right? And just place it here, right there, right? One would say, why did you do this? Now, place is basically a static variable or a static value that is going to be every time overwritten by 10 to the power of 4. There is nothing dynamic here. The point is to have the place being dynamic, meaning that in the first recursive call, place is being multiplied by 4 or to the power of 4, so we have 10,000. So when we have 10,000, we can multiply it with, as we said, for example, the first element, which is 1, so we have 10,000. Right? And it's going to be decremented by dividing it by 10 in the next recursive call. So 10, or place, is going to be 1,000 multiplied by the second index, which is 2, right? So this gives you 2,000. And if this was dynamic, if this was not being decremented, then there is nothing that is going to be driving that function into a stopping or into an end, meaning that if the place was from the get-go being 10 to the power of 4, and every time we recursively call this function, place is being overwritten when this line is executed to 10 to the power of 4, then we will never get to that base condition. We're never going to stop. Right? The index is going to drive the functions or the recursive function to check the other element, the other element, the other element, but there's nothing that is going to stop it, right? So if I run this, I'm going to get one of two errors. One of them is basically maximum recursion depth has reached, or index out of range, and I think I'm going to get, yes, index error, index out of range. And the reason for that is that we will never reach to this base case. We will never get out or stop this recursive calls, right? But instead of going to the maximum recursion depth, one thing that is going to be raised, one error that is going to be raised, is that you are incrementing the index every time, and you are indexing that string every time as well, right? So at one point, you're going to have I is going to be equal to 5. So we have from 0 to 4, where it's going to tell you that there is no I of 5, there is no index of 5, right? So that's why this is an index out of range thing, right? So let me just tweak this place a little bit, right? I don't want to change anything in the code. I want to leave everything as this. But is there a way to convert this from a static defined value into a dynamic value that's going to be decremented by, for example, 10 every time? Well, the solution is this, and this is really straightforward. by adding, it's the same trick that we did in the bubble sort in order to make it a little bit improved, a little bit well at the performance perspective. And we did something like minus I. See, this is the part that's going to put everything in place. Now, if you look at this closely, if we have 10, right, to the power of len, right, of that string, which is going to be 5 in the first iteration, right? So this is going to be, let's say that this is going to be 5. This is the length. Minus I in the first iteration, which is 0. Minus 1. So this is going to get you what? This is going to get you 4. So 10 to the power of 4 in the first iteration, this is going to get you 10,000. And 10,000 multiplied by 1 is going to work, right? It's going to get you 10,000. Right? In the next iteration, let me just take this away. In the next iteration, we will have 10 multiplied or to the power of len of s, which is going to give you as well 5, right? The length is the same. Minus I in this iteration, where I is going to equal 1. Minus 1, this is going to get you what? This is going to get you 3, right? So 10 to the power of 3, this is going to get you 1,000. Multiplied by s of I, which is in this case 2, right? So this is going to get you 2,000 plus the previous here. The addition is gonna, the accumulation is gonna happen here, plus the previous 10,000. So this is gonna get you. Oh, let me just without the additions, without the addition part. Let's just take it one by one. Let's just take every element. Let's talk about the known part right there. Okay, so if now we take len of s, right? So this is gonna be, as I told you, 5, right? Minus I is going to be, in this case, if this was 0, 1, this is gonna be 2, right? Minus 1, right? So this is gonna be what? This is gonna be 2. 10 to the power of 2, then this is 100 multiplied by the current s of I, which is in this case, we're talking about index of 2, then this is 5 typically. So this is going to get you what? 500, right? So this is basically the solution. And if you notice something, this is the same result. That's the same result, right? There is another way. There is another way if you don't want to use the optional parameter. It's basically using slicing, right? That's just the same as we did with this get constants thing. So try to do this on your own. And if you find any struggles, just message me with the current code that you have reached. All right. Well, I thought to myself before I end the video, since this is going to be really easy, that let's just do the version if we didn't need any optional parameters. Like I don't even want to have to see that index. It's the same idea that we did with the get consonants problem, right? So now I don't have an index, right? So instead of traversing using the index, I can just say that I'm gonna always have at least the first element to check, which is index of 0, and every time I'm just gonna slice that string from the second element up to the last element, right? So in the next recursive call, I'm gonna pick index of 0, and I'm going to slice it from 1, which is 5 in this case, to the end. In the next recursive call, 5 is going to be index of 0. I'm going to slice it from 1, which is 3, to the end. In the next recursive call, 3 is going to be index of 0. I'm going to slice it from 1 to the end, right? So when we reach to a place where the length of the string is basically 1, meaning that we reached 4, the last index, then I can just return the that element, which is index of 0. That's the only element that I have, right? So everything is going to make sense except this part, since we don't have an I anymore. But typically, if you remove the I, it would just make sense, since every recursive call, the string is being sliced, it's being minimized, right? So this is going to be guaranteeing for us the dynamic part that we wanted to achieve via the I in the previous version, when we had the index being passed as an optional parameter. So if you run this, you're going to have the same result.